Okay, nonlinear systems, the mother of all problems, arguably the most difficult thing we've done. So you have to really be very careful with these. I'm going to do the question one first. Most people, I think, did this one all right. You have a positive y and a negative y, so it's kind of just screaming for you to do elimination. I will point out that if you really, really, really wanted to, you could do this problem by substitution, but why would you? Substitution in general is a lot more complicated than elimination is. And all I have to do is add these straight up and down and cross out the y's. And then when you add, remember, equal sign and equal sign is bigger equal sign. 14 and 10 make 24. Now on this side, remember, if you're adding these together, these are not like terms. You can't combine them into one thing. This is an apple and two puppies. An apple is like, oh, it's 2x to the third, or it's 3x to the third, or it's 2x squared, or it's 3x squared. I mean, it could be anything. No, it's not any of those. An apple and two puppies. Can't combine them together. Set it equal to 0, right? Subtract the 24 over. If you really insist upon me writing that step down, I can. I don't want to. Factor this. Now, this is where I disappointingly saw some people factor wrong. There's a lot of pairs that make it 24. You got to pick the pair that will get a 2 in the middle when you subtract them. So that would be positive 6 and negative 4. Set each one of these equal to 0, right? X plus 6 equals 0. I'm not going to do this, all right? I don't want to, I'm skipping these steps at this point. We're doing a more advanced, sophisticated problem. So I'm going to save myself 2 seconds of work. Switch, switch, right? You set them equal to 0, you solve. It's almost over, except I have to use one of those two original equations that I totally ruined and solve for y. This one has a negative y in it. I'd rather not use that one if I'm going to solve for y. Why not just use the top one? The top one already has a positive y there. So I'm going to plug my two numbers that I got for x into there one at a time. First, I'm going to plug in negative 6, and then I'm going to plug in 4. First, take the negative 6 and put it where the x is. Be careful. You know, you're going to get a number that's not too small here. Negative 6 times negative 6 is positive 36, right? You have to subtract 36 from both sides. So you get y equals 14 minus 36 is 22, I believe, negative 22. So when x was negative 6, y was negative 22. It's just a value that you get. Every time you plug in a different x, you're going to get a different y. This time I want to plug in x is 4. So replace the x with the number 4. 4 times 4 is 16. Now I have to just one more step, right? 16 subtracted from both sides. Cross it out. So you get y equals 14 minus 16 is negative 2. So when I plugged in x is 4, I got y is negative 2. That's where the graphs meet. You have a parabola and a line. You don't have to graph these. I mean, I could show you, but I won't. So that's the first one. Question number 2. This is by far the hardest of the 4 because it requires a lot of very advanced steps. Now, the first step is the most important step, believe it or not. You have to solve, one of these equations is more complicated than the other one. You are not going to solve the top one for x and then put it down here. It's not happening. You have an x squared, right? You'd have to do the square root. There's no way that's happening. You can only solve the bottom one for x or y and then plug it into the top one, right? You have to do substitution here. You cannot do elimination. You have an x squared and an x and a y squared and a y. If that was a y squared, you could do it, but it's not. So you have to solve. Now, it's easy to just do plus y to both sides, right? Cross that out, and you get x equals y minus 3. That is by far the easier letter to solve for. Can you solve for y? Yes, you can. You can subtract the x over and then divide by the negative 1. That's more advanced. It's more complicated. Why would I create more work for myself? I don't want to do that. I want to take the path of least resistance. The easiest thing in the world to do here is just to do plus y and get y minus 3. Don't write negative 3 plus y in this case. You should just write y first because we're used to the letter being first. Now, I'm going to take that and go put it, the original equation had x squared plus y squared equals 29. This was an x. I'm going to replace the x with what it's equal to. So the x is not there anymore. What was x equal to? Y minus 3. So you put a y minus 3 there. Now, on the side, if you have to do what's y minus 3 squared, that means you do y minus 3 times itself. Y times y, y squared. Make your foil rainbow. The inner and the outer. Negative 3y, negative 3y. You get negative 6y, right? The inner and the outer, right? Foil, first, outer, inner. So you make the foil rainbow. You get the inner and the outer. And then negative 3 times negative 3 is positive 9. So this whole dude over here was that. How about the rest of it? Well, the rest of it's still there. You see that plus y squared? It's still there. You see that equal? It's still there. And that 29? Still there. All I did is replace the x with y minus 3. I multiplied it out. Everybody else is still there. Now I got to see if I can put some stuff together. You have a y squared and another y squared. That gives me 2 of them. 1y squared and 1y squared is 2y squareds. Not y4, right? Same creature. They don't change. Minus 6y plus 9 equals 29. It's almost over. I'm going to move this to that side. Why am I going to do that? Why am I going to subtract 29? Because I want it to be equal to 0. Pow. So I have 2y squared. Let's see how smart I am. Negative 6y. Stayed the same. Stayed the same. 9 take away 29 is negative 20. Yay! Why am I saying yay? 2, 6, 20. They're all even. Well, I'm going to factor it with the 2 there. You can factor it with the 2 there. But why should you? Why would you? If you can divide all these numbers by 2, if they're all even, this is a valid move. Make that move. Now, I'm going to erase this because I don't need it there. So I'm going to cut all these numbers in half. Divide them all by 2. What about 0? Listen, what's half of no cookies? Half of no cookies is no cookies. So 0 divided by 2 is still 0. So cut everything in half. You get y squared minus 3y minus 10 equals 0. Isn't that easier to factor? Since you're not there to answer me, hell yeah. I don't want to factor with a 2, so I cut them all in half. Now, keep going. Remember, I'm solving for y this time. So I'm going to use 5 and 2, right? And then negative and plus. Negative 5 plus 2 is negative 3 when you add them together. And when you multiply them, you get negative 10. So here you get y minus 5 equals 0. So y is 5. Y plus 2 equals 0. You get negative 2. Again, I'm not showing that step. We're a little bit beyond that now. And we're doing a more complicated problem. So we're going to skip the nonsense. I got to plug these numbers I got for y. Don't put them up here. I'll tell you why in a minute. You want to go simple, right? You already have this nice equation in a box that tells you what x is in terms of y. So just put y equals 5 first. Boom, x is 2. I mean, how easy was that? Now remember, x goes first. X is 2, y is 5, right? When I plugged in y is 5, I got x is 2. It's reversed because we got y first. When y is negative 2, put a negative 2 there, right? There's y, put a negative 2. Negative 2 take away 3 is negative 5. So I get the point negative 5, negative 2, right? X, y. Those are my 2 points. If you try to solve them against the top one, remember, a circle has a lot of points on it, but the circle and a line are only going to meet twice. If you were to plug y is 5 up into here, I want you to see what happens, because it's very important, because if you do this, it's a mistake, and you're going to end up getting it wrong. That's 25. Then you get x squared equals 4, right? Subtract 25 over. So you would get x equals plus and minus 2. So you get x equals plus 2 and x equals minus 2. So then you would think, oh, all right, so I get the point 2 comma 5 and negative 2 comma 5. But notice, I don't have both of these points. You're getting points on the circle. but you get extra points that aren't there. You get points that are on the circle that are not on this line. You need the points that lie only on the line. That's why you want to use only this equation to solve for x. It's going to screw you up. You're going to get extra points that aren't on the line. So it doesn't work. If you try to take the other point and plug it in here, it fails. So those are the only 2 points that work. So you have to be very careful when you're doing your solving for the second letter. Use the one you already have. You already have one there to plug into. Don't try to get cute and go into the top one, because you end up with points that aren't on the graph at all. Okay, number 3, also an elimination problem. Can you use substitution? Yes, you can, but you shouldn't. Now look, this would be perfect if this was a negative. So let's make it a negative. I'm going to take the bottom equation. That looks like a 51. I'm going to take the bottom equation and multiply it by -1. This is going to make a positive, and then a negative, and then a negative, right? Multiply the entire bottom equation by a -1. Now, I have the benefit of being able to cheat. Make this one a plus, make this one a minus, and make this one a minus. And now, add them straight up and down. The positive y squared and the negative y squared cross out and go away. The equal signs make a bigger equal sign. 25 minus 5 is 20. Now again, how do you add x squared plus x? You don't. They are not like terms. All you can write is x squared plus x. Easy peasy. Switched all the signs, add them together. Subtract that over, right? Subtract 20 from both sides. Why? Because I want to set it equal to 0 and factor it. It's easier. What are you going to do? Use the quadratic formula? Knock yourself out. I see you do that. I'm going to be really unhappy. It's got to be 5 and 4. 5 times 4 multiply to be 20. When you subtract 5 and 4, you make a 1 in the middle. So I know I'm good. So I got x is -5, and I got x is +4. Now I just need to get y. I mean, this problem is elimination is way faster and easier. I mean, I'm at the end of the question now. All I have to do is just figure out what y is. The bottom equation, because I switched it, it has a negative here now. So I'm going to use the top one. It doesn't matter which one you pick. You will get the same. In this case, it's not going to matter. You're going to get the same answers, regardless of what you do. So in the previous problem, though, it mattered which one you plugged into. You didn't want to plug into the squared ones. Here you have to. I mean, they both have squares in them, so it doesn't. Whether you plug into the top or the bottom, you have a y squared and you have a y squared. So you're still going to get multiple solutions for y, regardless of whether you use the top and the bottom. In the previous example, the bottom equation had only x and y. So I had to use the one with x and y and not the one with the y squared, because I got these extra answers that didn't work. So, if that confused you, then just ignore me. But you have to be careful on certain questions. This one, I don't have to be careful. I have y squareds in both examples. So take -5 and plug it into the top one for x. I'm realizing I don't have a lot of room here. I should have started over more. -5 times -5 is 25. Plus y squared equals 25. Well, look at this. Subtract 25 from both sides. Pow, pow. So you get y squared equals 25 minus 25, which is 0. When you do the square root of 0, 0 is not positive or negative. It's both. And it's neither. You get 0. So you only get one answer there. You get -5, 0. When x was -5, y must be 0. One easy peasy solution. Yay! Now replace x with 4. Okay, wherever you see x, you put a 4. Multiply it out. 4 times 4 is 16. Now remember, this time I got a y squared there. Not a y. Makes all the difference in the world. Subtract 16. You get y squared. 25 take away 16 is 9. Yay! Now you got to do square root, right? How do you solve this? I mean, you can set it equal to 0 and factor it, but why would you? You can do it quick and easy. Don't forget to put a little plus and minus there. It's very easy to just go, oh, radical 9, 3. Got that shit all day. Oh, you got half of it. I mean, it's not going to cost you a lot of points, but it's going to cost you points because you missed one of the answers. So here we get y equals plus and minus 3. So what does that mean? It means that when x is 4, I could either get a 3 or a minus 3. So you get 3 separate points where those graphs meet. Those are the 3 spots where they meet. It is what it is. The bottom one is like a sideways parabola, and the top one is a circle. So they meet something like this. They meet 1, 2, 3. You don't got to draw this crap. I'm just showing you. All right. Sometimes they hit 3 times. Sometimes they hit 4 times. Sometimes they hit twice. Sometimes they hit once. You never know how many times they're going to hit. The next one I'm about to do, they're only going to hit once. You don't know. You just have to solve the question. So, this one comes out a little bit nastier than number 1, but, and it's got more solutions. You just have to be very careful with it. All right. Finally, number 4. X squared, X. Y squared, Y. Right off the bat, elimination not happening. Like, ooh, I like elimination. Elimination is the best. And it is. Elimination is much easier and faster. So this problem is more advanced. So you got to do substitution. So you have a decision. Do you solve for X or do you solve for Y? Now, in this case, if I solve for X, I'd have to subtract Y and then divide by -1. Again, this is more work than I want to do. If you want to do that and knock yourself out, you certainly can. But I'd rather solve for Y. So I'm going to do plus X to both sides. I'm going to add X. That crosses that out. So I get Y equals X plus 1. Yes, you can write 1 plus X. It's the same thing. But why not just write X plus 1? So now I know what Y is equal to. So I'm going to go back to my original problem. Remember, there's a Y here. But I don't want the Y. I am going to substitute X plus 1 where the Y is. Now, you got to be real careful. That negative sign, very dangerous. It's in a dangerous spot. You can't do anything with it right now. Just leave it there. What I can do, though, is tell you what X plus 1 squared is. I'm going to do it on the side. X plus 1, X plus 1. X times X is X squared. Do the inner and the outer. You get 1X and 1X. That's 2X. And then 1 times 1 is 1. I don't like the way that fit. Too tight. There we go. Equal 3. Take the Y. Replace it with X plus 1. Multiply it out. Now, I am subtracting away that whole thing. I'm not just subtracting him. I'm subtracting everybody that's there. If you don't put these parentheses here, and you just do -X squared, you just screwed up the whole thing. He's got to switch. He's got to switch. You need those parentheses there until you have dealt with the negative. If this is a plus, you don't got to worry about it, right? Adding doesn't change anything, but subtracting changes shit. Subtracting changes the signs. So now you got to distribute that minus sign to everybody. Hop the fence and say hello to everybody in the party. Switch, switch, switch. Switch them all. X squared, not -X squared. A positive 2X becomes -2X. And a positive 1 becomes a -1. You got to switch them all, or else it's wrong. So this is a very easy mistake to make. So don't feel bad if you did it wrong. Now, what's X squared minus X squared? If you have a puppy and I take your puppy, you're going to cry. You'd be very sad. You have an X squared. I took it from you. You don't have an X squared anymore. It's gone. So what's left? Well, you have a -2X left. That's it. You now have a linear equation. You don't have X squared no more. No more factoring. You don't factor this. How do you solve an equation with X? You get the X on the left and you get the number on the right. Add 1 to both sides. Cross that out. So you get -2X, right? -2X, that's gone now, equals 3 plus 1, which is 4, right? Letter on the left, number on the right. This is how you solve a linear equation. The X and the number have to be on opposite sides. Divide by -2. Pow, pow. 4 divided by -2 is -2. Oh my God, I just got one answer. What am I supposed to do with that answer? Where am I supposed to put that answer? I don't know what to do with it. Right here. Got to put it there. So you get Y equals -2 plus 1, right? Replace the x with -2. -2, you owe me 2, but you pay me 1, you still owe me 1. Yay! That's it. This problem only has one answer. They only meet one time. Hyperbola and a line. They only meet once. You don't have to worry about what the hell this is. All right, now I will point out again, if you decided to plug x equal 2 up there, see, this is where you can make the mistake. You always got to plug back into here. I mean, you have this nice convenient equation, but let's say I decided to put it into the top one. That's going to be crazy, right? -2 times -2, +4. Subtract 4 from both sides, you get -y squared equals -1, right? 3 minus 4 is -1. Switch the signs, you get y squared equals 1, and then do the square root. So you get y equals plus and minus 1. See, you would get y equals 1 and y equals -1. Because of the y squared, it introduces an extraneous extra BS answer. That's why you cannot use the top one to solve for y once you know what x is. Once you get x, you plug it into the one you already built and get y. Do not go back to the top in this example. They're different. Y squared and y are not the same creature. You will get extra fake answers up there at the top, and you won't know they don't work unless you put them into the bottom to check it. And if you notice, I didn't check any of these answers. I should have been. I didn't check any of them to see that they work. I mean, you could always check them yourself on the side. All right, so these problems, very nasty, very complicated. Take your time, decide what you're gonna do, but I'll tell you eliminate, substitute. I mean, I'll give you that hint. So I don't want to leave it up to you. It's like, which one do I do? I'll tell you, eliminate, substitute. So you know exactly what to do. I can even tell you what to solve for to help you out. All right, so good luck with the rest of them. Do them all, do all the ones on the sheet, because I'm gonna take those exactly the way they are without changing the numbers or the signs and put them on the quiz, put them on the test. I'm not even gonna change them. So make sure you do all of them.